In part 4 of lecture 6, we will discuss constructing an LR0 state machine. We're now ready to construct the next set of states. The dot before the E tells us that we have not yet found that E or traversed it. As we go to state 1, you'll notice that as we traverse the E, the dot has moved to the next position. What that means is that everything that we were looking for that would comprise an expression has already been found. Now you'll notice in state 1 the dot is now before the $sign, the end of file marker in the first production, and in the second it is past the E and right before the plus. Both the end of file marker and the token plus are terminals, so we don't need initial items describing what they are. In this state, you will see a dot for letter T. In this case, what it means is that as we were getting ready to traverse expression, we realized that there can be more than one way in which we can have this expression show up in our grammar. It might, for example, simply be a single term. So when I move into state 2 with transitioning over T, what this means is that the dot at the end tells me that I have found the entire term. This is a final item. In this case, I'm going to show the transitions slightly out of order. In this particular case, what you'll see is I've gone all the way down to T derives .f. What this means is I'm getting ready to find what I need to have a term, and the only thing that I have in a term in this case is the non-terminal factor. By going to the next state, where transitioning past factor means I will again have a final state. As we process the next transition, transitioning past the plus sign, in term derives dot plus factor, I see that the dot has gone from being before a terminal to being before the non-terminal factor. That means I am going to need initial items for factor. State 5 looks a great deal like state 4. In both cases, I have T derives dot, some additive operator, factor. By moving the dot beyond the minus sign, what it means in this case is that I am going to have the dot in front of the non-terminal factor. Again, as before, that means I'm going to need initial items for factor. Here we add state 6. Before we had factor derives dot identifier, now it's factor derives identifier dot. Here we have the last transition coming directly out of the initial state. F derives dot constant after we traverse past the constant becomes F derives constant dot. We now have all the states that will be one transition away from the initial state. State 1 is not going to be a final state in any sense of the word. Both of the two items in it are non-final items. With the dot in front of a $sign, the end of file marker, if I transition past the end of file marker, I will end up in state 12. If, on the other hand, I run into a plus, I'll go into state 8. Now, in this case, you'll notice the dot now is in front of T, a non-terminal. That means I'll need initial items for term. Now, given the last one of these is T derives dot F, I also need initial items for F as well. State 2 and state 3 are both final items. The dot is at the very end of the item. State 4 is a different case. Now I start out, I have T derives plus dot F, and the transition from F will be to state 9. T derives plus F dot. On identifier, we will transition to state 6. F derives ID dot. Similarly, on constant, we will transition to state 7. F derives constant dot. Now, these are states that we already have, and they are all, you'll notice, one state away from state 0. The fact that we will end up in a state that was previously drawn should not be surprising. It will happen quite frequently. State 5 is more or less the same as state 4, except for the minus sign instead of the dot. Again, here we have the same three transitions based on F, based on identifier and constant. State 11 will be different from state 9 in that the final item in state 9 is t derives plus f dot, whereas in state 11 it's t derives minus f dot. The transitions to identifier and constant will be exactly the same as they were in state 4. States 6 and 7 are final states. This brings us to state 8. We have a transition on t, and you can see it here taking us to state 10. E derives e plus t dot. Where we have the dot before the f, this will take us to state 3. The dot before plus will take us to state 4. The dot before the minus will take us to state 5. The dot before identifier will take us to state 6. And the dot before constant will take us to state 7. This is the machine as we have it, and it's now complete.